Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice exponential equation problem, and here we have 2n plus 6 to the power of n square minus 9, and it is equals to 1. So we will solve this problem for the values of n. So in this question we will find all the solution which is satisfied this equation. So here I can divide this solution by three cases. The first case is, here we need any cases or any possibilities in which you will get the answer or output is 1. So here I know that the first possibility which you will get the output is 1 is if you have some exponential equation, and then you will write it as, if you have some base and its exponent 0, then you will get its answer or output is 1. This is the case number 1. And similarly, in case number 2, you will get the output 1 is that if you have 1 to the power of k is equals to 1. So the second case is, if you have base is 1 and exponent is any number, then it will becomes equal to 1. So here you make a condition which is k is not equal to 0, because if k is 0 then it will be undefined. And the third case is, I can write it here, if you have the power of negative 1 is some even number which is 2k, so it is gives the output is 1. So here we have three cases in which you will get its output is equals to 1. So now I can solve these three cases one by one. So now first we move towards the case number 1, and in case number 1 you will compare this case on this equation and both of the sides. So here first you compare its left hand side, and here you see that the exponent, or when you compare exponent in the left hand side, you will get here n square minus 9 is equal to 0, and when you compare base you will get 2n plus 6 is equal to k. So here I can write, when you compare exponents it will becomes n square minus 9 is equals to 0, and when you compare bases it will becomes 2n plus 6 is equals to k. So now here you remember one thing is that over this k is not equal to 0. When you find the values of n and put here, you will get this k is not equal to 0. So now first I can find the values of n here. So here we move this 9 in the right hand side, and you will get here n square is equals to 9, and here we get n is equals to plus minus 3. So now I can check the values of these values of n which is satisfy this equation, and here you remember one thing is that this k is not equal to 0. So we choose those values which satisfy this condition. So now first we will put here n is equals to 3, and you will check the value of k. So when you can put here 3, you will get 2 times of 3 plus 6 is equal to k, and you will get here k is equal to 6, and here you see that it is not equal to 0. So this means that n is equal to 3 satisfied this condition. And now when you will put here n is equals to minus 3, and you will check the behavior. So when you will put here, you will get 2 times of minus 3 plus 6 is equal to k, and it will become 0, because minus 6 and plus 6 is equal to 0. So here you get k is equal to 0, but here we say that in this case k must be not equal to 0, so that we will rejected this case. And here we have only one solution, which is n is equals to 3. So in the first case you will get the solution is, the first solution is n is equals to plus 3, because minus 3 is not satisfied. Similarly we move toward the second case, and in the second case we have 1 to the power of k is equals to 1, and now again you will compare this case on this equation. So when you compare left hand sides, you will get the base is 2n plus 6 is equal to 1, and its exponent is n square minus 9 is equals to k. So in this case, here we have k is any number. So here you can just compare its bases and you will get 2n plus 6 is equal to 1. So now we can solve case number 2. So in case number 2, its bases are 2n plus 6 is equals to 1, and here you will easily get the value of n, which is 2n is equals to 1 minus 6, and you will easily get 2n is equals to minus 5, and n is equals to minus 5 over 2. So this is the second solution of this problem. So this is the solution number 2, and now we can solve the case number 3. So in case number 3, we will just check its, or we will just compare the left hand sides, and when you compare the left hand sides in case number 3, you will get its base is 2n plus 6 is equals to minus 1, and here you remember one thing is that its exponent must be the even number, because here 2k is even. And now we first compare its bases and we check its exponent is even. So we will get here 2n plus 6 is equals to 2n plus 6 is equals to minus 1. This is the basis of both of the cases, and its exponents are n square minus 6 is equals to 2k, or I can just write this 2k by even. If you take base 2n plus 6 is equal to minus 1, then you must be get its exponent is even number. So now first I can find the value of n here, then you will easily get n is equal to 2n is equals to minus 7, and n is equal to minus 7 over 2. So here you get the value of n, and now you can check this value here and you will get its right hand side is even number. So now we can put here, and you get minus 7 over 2 square minus 6 is equal to even. So here we just check. So you see that 7 square is 49 over 4 minus 6 is equal to even, and when you can solve these equations, you will easily get here the value is 13 over 4, and you can see that 13 over 4 is not an even number. So that if it is not even number, then we will rejected this case, or this case is not satisfied. So we will rejected this case, okay, because it not satisfy the case number 3. In case number 3, it is only equal to minus 1 when its exponent is even, but it is not even, so it is rejected. So finally here we have only two solutions of this problem. The one is n is equal to 3, and the other solution is n is equals to minus 5 over 2. So these are the two solutions of this problem, and this is our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.